Hi, and welcome to Section 1 of the complete AB-100 AI Solutions Exam Prep course. I'm Chuck McCullough, and since this entire exam is focused on building agentic AI, I thought it was only fitting to bring along a specialized AI co-host for the journey.
Hello, everyone. I'm thrilled to be here. Over the next couple of hours, we are going to cover the absolute foundations of the Microsoft AI ecosystem.
Exactly. We'll look at Copilot Studio, Azure AI Foundry, and dive deep into the plan domain of the exam. That means we're analyzing business requirements, accessing data readiness, and calculating ROI.
To make it easy for you to study uninterrupted, we have stitched together the first 3 sections of the premium course into this single masterclass.
Now, this is a long video, so use the timestamps in the description below to jump around to specific topics, and make sure to subscribe so you don't miss part 2 where we get into the heavy architecture and design. And what happened to your hair? Anyway, are you ready to get this started?
Yes, Chuck. I am ready to get started.
Uninterrupted. This course is structured around one central goal: getting you certified on the AB-100 exam. But we're not just teaching you test-taking strategies. We're building a comprehensive understanding of agentic AI from the ground up. Here's what's inside. First, foundational knowledge. You'll understand what agentic AI actually is, not just the hype, but the real mechanics. What makes an agent different from traditional automation? How does it think, learn, and act? We'll demystify that architecture and show you how these systems work in practice. Second, practical skills. You'll learn to design agentic workflows, understand orchestration patterns, and navigate the Microsoft ecosystem for building these solutions. These aren't theoretical. They're the same patterns used in enterprise environments right now. Third, exam alignment. Every lecture is mapped to the AB-100 exam blueprint. You'll know exactly what you need to know, and we'll highlight the concepts that show up most frequently in the exam questions. And finally, confidence. By the time you finish, you won't just be memorizing answers. You'll understand what's behind each decision point. This course is designed for business and technical architects that need to understand agentic AI design, project managers and product leaders responsible for agentic AI initiatives, and technical professionals transitioning into AI-focused roles, and anyone preparing for the AB-100 exam and wanting to understand the material deeply. You don't need to be a machine learning expert or have deep Python experience. We assume you have some basic knowledge of cloud concepts and business process, and that's enough to get started. Now, the AB-100 requires an active associate level Microsoft AI certification as a prerequisite. So you need to grab that before you take the AB-100 exam. All right, now we've organized this course into 7 sections, each building on the previous one. So section 1 is welcome and course orientation, where we are right now. Section 2, Microsoft AI platform and ecosystem foundations. That's the tools you'll use. Section 3, plan AI-powered business solutions. This is requirements and strategy, and that's a chunk of the exam. Section 4, design AI-powered business solutions, architecture patterns. Then Section 5, deploy, govern, and secure AI solutions, enterprise-grade practices. Section 6 is on exam prep and practice. This is where we have our mock test. And then the last section, 7, is where we wrap it all up so you can go take the exam. Now, here's my recommendation for getting the most out of this course. Watch actively. Don't just play these videos in the background. Take notes on concepts, especially if they surprise you or you feel unfamiliar. And just pause when you need to. Engage with scenarios. When we present real-world examples, think of how they apply to your work context. That's where the learning sticks. Also, budget your time. This course is comprehensive, but it's paced for busy professionals. Plan for about 45 to 60 minutes per lecture, plus some time for quizzes. Most people will complete this in about a month. Before we go deeper, let me clarify something important. Agentic AI is not just another automation tool. Traditional business automation is usually rule-based and linear. You define a process, like if X happens, then do Y. It's predictable, but it's brittle. When something unexpected happens, the process breaks or even needs human intervention. Agentic AI is goal-oriented and adaptive. You tell an agent, here's your goal. Here are your tools. Go figure it out. The agent perceives its environment, reasons through the options, takes actions, and adjusts based on feedback. It can handle ambiguity and novel situations within the guardrails that you define. If you want a visual here, think of a linear flowchart versus a feedback loop that reevaluates as new information arrives. This is why agentic systems are transformative. They can handle complex, unstructured business problems, things that traditionally required human judgment. Customer support escalation, contract negotiations, supply chain optimization, strategic planning. These are the domains where agents are creating value today. But, and this is critical, this power comes with responsibility. We'll talk extensively about safety, governance, and risk. You can't just deploy an agent and hope for the best. The AB-100 exam has 3 main domains. 1, plan AI-powered business solutions. That's about 25 to 30%. Design AI-powered business solutions. That's about 25 to 30% as well. And deploy AI-powered business solutions. That's 40 to 45%. That includes governance, evaluation, and security. So it's a much bigger section. Keep these in mind as the backbone for everything we cover. The exam itself is about 50 questions, and they allow 120 minutes. Some of the questions are knowledge-based, but most are scenario-based. You're given a business problem. Which approach is best and why? That's why we focus on understanding and not memorization. The exam is not testing deep machine learning knowledge or even coding ability. It's testing whether you understand how to plan, design, and deploy agentic systems in a business context. That's what we're training for.
You are going to love the next topic. Are you ready to start?
Agentic AI is a system that can pursue a goal, select actions, and use tools to achieve outcomes, often with minimum human intervention. That's the exam-ready version. Now let's unpack it in plain language. Goal-oriented means it's not just reacting, it's trying to achieve a target. Action-taking means it can decide what to do next, not just respond. And tool means it can call APIs, trigger workflows, query data, or delegate steps to other AI agents. In the Microsoft ecosystem, think of Copilot Studio agents calling connectors or Foundry Tools for custom models. If you remember one sentence, remember this. Agentic AI equals goal plus reasoning plus tools plus action. Let's define the terms that you'll see in scenarios and multiple choice questions. The goal is the target outcome. Reasoning decides what to do next. Tools are the traditional APIs, workflows, and data sources. Finally, action executes steps to reach the goal. So here's some quick definitions. The agent is the decision maker that chooses actions to reach a goal. The tools are there for the agent to use. These are APIs, workflows, data sources. Orchestration is the logic that coordinates the steps and the tool calls. Planning is the process of breaking the goal down into smaller steps. And then finally, memory is what the agent retains to stay consistent over time. And finally, guardrails are the safety and compliance constraints that keep the agent aligned with business policies. So here's a useful analogy. Think of the agent like a project manager. It receives a goal, figures out the steps, uses tools and people, and adapts as new information arrives. Now, this part matters for the exam. Many wrong answers describe systems that are not agentic. It's not just a chat bot. Chat can be part of an agent, but an agent takes actions. It's not just traditional automation either. If it's purely if X, then Y, it's not agentic. It is not a standalone model. The model is just one component of your agent system. Here's a simple test. If the system can't decide, act, and adapt, it's probably not agentic. Faster decisions through automated reasoning and reduced operational load by delegating routine tasks. It's scalable workflows that adapt to real-world variability and better alignment between technical systems and business goals. In the exam, these benefits show up in scenario questions. You'll be asked to choose solutions that deliver business impact, not just technical novelty. Let's lock in the essentials. Agentic AI is goal-driven, tool-using, and action-taking AI. Here's some key terms: agent tools, orchestration, planning, memory, and guardrails. It's not just chat or automation, it's decision, action, and adaptation. The exam emphasizes business impact and safe deployment. The AB-100 is delivered as a computer-based exam through Microsoft's official testing platform. Here are the critical numbers that you need to know. You'll face 40 to 60 questions, and you'll have 120 minutes to work through them. The passing score is 700 out of 1,000, 70%. The exam uses a mix of question types: multiple choice, scenario-based questions, and some drag and drop. The exam costs $165 and it's delivered online with a proctor watching. The easy questions go fast, maybe 10 to 15 seconds. The scenario questions can easily eat up 2 to 4 minutes, and that's where your strategy really matters. Let me give you some realistic breakdown of how you should think about your time. The knowledge questions, the straightforward questions, should take you 10 to 15 seconds. Answer them and move on. If you have a question about one, flag it. Multiple select questions where you have to pick all the correct answers, those are going to take more, about 30 to 45 seconds, because you just can't pick one. Scenario-based questions are your time sinks, 2 to 4 minutes each. You need to read carefully, understand the business context, and reason through the options. And here's a smart move. Reserve about 10 minutes at the end to revisit the questions that you flagged. Now, why does this matter? Because the exam is adaptive. If you absolutely crush your first 20 questions, the next batch will be noticeably more difficult. If you struggle, they get easier. So your early performance actually shapes the rest of your test experience. Let's talk about the actual question format you'll encounter. First, multiple choice with a single answer. You see 4 options, you pick one. These are the most common question type on the exam, and they test whether you understand concepts and can apply them. Then there are multiple select questions. Same idea as multiple choice, but you have to identify all the correct answers. This is trickier because you don't get partial credit. You have to get it right on every selection or the question counts as wrong. That's why those not only feel harder, but they are harder. Scenario-based questions are the meaty part of the exam. You read a business situation, maybe a company wants to deploy an agent to handle something, and then you answer 2 or 3 follow-up questions about that scenario. These test real-world reasoning, not just definitions. And finally, drag and drop questions where you match terms or you sequence steps. These show up occasionally, but they're not that common, really. Let me be very direct about what the exam is and isn't testing. The exam is testing your ability to reason through real-world scenarios. It wants to know if you understand trade-offs like speed versus safety, autonomy versus control. It's testing best practices for design and deployment. It's asking, can you map a business problem to the right agentic approach? Can you think ethically about governance? These are real questions on the exam. The exam is not testing deep machine learning theory or mathematics. You don't need to know linear algebra or calculus. It's not asking you to write code or demonstrate programming ability. It's not about training models or fine-tuning models. And it's not quizzing you on specific API syntax like Azure or any particular tool. This is critical to your study plan. The AB-100 is a business and architecture exam, not a machine learning engineer exam. If you can understand why and how to deploy agentic systems responsibly, then you're going to succeed. Here's a mental framework that will help you when you're staring at a scenario question on test day. Follow these 5 steps. Step 1, identify the business goal. What is the company actually trying to achieve? Is it cost saving, faster response times, better customer experience? Get specific here. Step 2, spot the constraints. Is there a budget limit, a timeline, regulatory requirements, compliance concerns? These will shape your answer. Step 3, recognize why an agent fits the challenge. Why is agentic AI the right solution here? Is the company trying to automate complex decisions? Do they need reasoning plus tool use? Step 4, evaluate your options. Which answer choices actually balances capability with safety? In step 5, this is the key differentiator, choose the balanced answer. The right answer usually doesn't maximize capability at any cost. It looks for trade-off thinking. It respects guardrails, and it thinks about responsible deployment. Now let's lock in those essentials before we move forward. 1, the format is 80 questions, 90 minutes, adaptive difficulty, and you need 70% to pass. 2, your pacing matters. Simple questions go quick. Scenarios will need 2 to 4 minutes each. 3, you'll see multiple choice and multiple select, as well as scenario-based questions, as well as some drag and drop. 4, 3 domains make up the exam, but deployment is the heaviest weight. That tells you what to prioritize in studying. 5, the exam is fundamentally testing your business reasoning and your ability to think about safe, responsible deployment. It's not testing coding or deep theory.
I am ready to go. Let's get started.
Let's start with the big picture. This course is organized into 7 sections. Section 1 is orientation, core definitions, and the exam format. Section 2 covers the Microsoft AI platform and ecosystem foundations. 3 focuses on planning solutions. Section 4 is design, architecture, and integrations. Section 5 is deployment, governance, and security. And then Section 6 is exam prep and practice. And Section 7 wraps up with a final review. Here's the key takeaway. Deploy, govern, and secure is the heaviest weighted area in the exam, so it should get the most study time. This slide gives you the priority order with one glance. Start with deploy, govern, and secure, and then move to plan and design. Finally, round out your prep with platform fundamentals and scenario practice. That order mirrors how the exam is actually scored. Now let's translate weightings into a simple time plan. Aim for roughly 40% of your study time on deploy, govern, and secure. Plan and design together will get about 45%, and the remaining 15% should go to platform fundamentals and scenario practice. The point isn't perfection, the point is alignment. Your study time should mirror the exam weight, not your curiosity. If you're curious about something, go check it out, but it's not going to help you in the exam necessarily. Next, the habits that actually move the needle. First, active recall. Don't just read or listen. Explain the concept in your own words. Second, the scenario mindset. Always identify the goal, the constraints, and the decision. Third, trade-off thinking. Most correct answers are a balance, a compromise, balancing capability with safety. And fourth, review wrong answers to understand the reasoning, not just the score. These habits compound. If you build them early, scenario questions get easier later. Here's a repeatable strategy for scenario questions. Step 1, identify the goal. What is the business actually trying to achieve? 2, note the constraints, risk compliance, data access, timelines, things like that. Step 3, choose the safest viable option that still delivers value, that accomplishes the goal. Correct answers usually balance value and safety, not the extremes. Now, key takeaways. Now, let's lock in those essentials. 1, the roadmap mirrors the exam weightings. Deploy, govern, and secure is the heaviest. Allocate your study time by exam weight, not curiosity. Scenario questions reward trade-off thinking and business alignment. Here's something the exam is going to test you on repeatedly. Agentic solutions are almost never built on just one tool. Microsoft has a whole ecosystem of platforms, and the exam loves throwing scenarios at you where you need to pick the right combination. Picture this question. A company wants to automate customer support with escalation to human agents and integration into Dynamics 365 sales. Now, you got to figure out which platforms to combine. That's the game. And here's the key insight. The exam focuses on business alignment, not deep technical expertise in any single tool. You don't need to be a Copilot Studio developer. You need to know what Copilot Studio is and when it's the right choice versus something else. So let's quickly run through the 5 major platforms you absolutely need to know. First, Copilot Studio. This is your no-code agent builder. Quick deployment, easy to use, and it covers all 3 agent types. Second, Azure AI Foundry. And previously we referred to that as the Microsoft Foundry, but the technical name is Azure AI Foundry. This is the heavy machinery of custom tools, custom models, fine-tuning, and enterprise-scale orchestration. Third, Power Platform. Think of this as your integration layer. It has connectors, automated flows, and bridges everything together. Fourth, Dynamics 365. These are your domain-specific apps, sales, service, finance, supply chain. Each has its own embedded AI capabilities. And fifth, Microsoft 365 Copilot. This extends AI into the productivity tools that your users already live in, like Teams and Outlook and Word and PowerPoint and so forth. Let me break these down a bit more because understanding where to use each one is really the core of what the exam is testing. Copilot Studio is your go-to when you need to build something fast. All 3 agent types, task agents, autonomous agents, prompt and response agents, are part of Copilot. You can build them all here without writing any code. Seriously, you can go from idea to deployed agent in a few hours or a day or so, not months. Azure AI Foundry is where you go when the off-the-shelf stuff isn't cutting it anymore. You need to fine-tune a model on your company's proprietary data. This is where you go, Foundry. You need complex multi-agent orchestration, Foundry. Need models that understand your industry-specific terminology, you guessed it, Foundry. Now, Power Platform is the glue. It provides hundreds of connectors to ground your agents in real enterprise data. It bridges Copilot Studio to your back-end systems. Don't underestimate this one. It's how agents actually get work done in the real world. Now, Dynamics 365 is interesting because it comes with pre-built agents for specific business scenarios like Sales Copilot, Service Copilot. These aren't generic. They understand customer relationship, CRM, and the ERP concepts right out of the box. And Microsoft 365 Copilot, think of it as bringing AI to where people already work. Your agents can show up in Teams, help in Outlook, assist in Word. It's about meeting users in their natural workflow. Now, here's where it gets interesting. In real enterprise scenarios, these platforms don't work in isolation. They work together. Let me paint you a picture. An agent that's built in Copilot Studio receives a customer request. It needs specialized reasoning, so it calls a custom model hosted in Foundry. Based on that response, it triggers a Power Automation flow that updates a record in Dynamics 365. All of this happens while respecting the governance and security policies defined in Microsoft 365. That's not hypothetical. It's a Tuesday afternoon in an enterprise environment. Questions will often ask for the best combination of platforms. There's usually a trade-off that you need to navigate. Speed versus customization, cost versus capability, simplicity versus scale. The exam wants to see if you can think through these trade-offs. Let me give you the 4 things to remember from this lecture. 1, Microsoft AI ecosystem is modular. You can mix and match platforms to get the best fit. There's no single right tool for everything. Number 2, AB-100, test platform selection based on business requirements. They give you a scenario, you pick the platform combination. 3, always factor in governance, scale, and cost in your answer. The exam loves these considerations. You always need to make sure that there's some security, even if you have to compromise some other feature that's required in the scenario. We always want governance and security to be part of that answer. Number 4, know when to pick speed with Copilot Studio versus customization with Azure AI Foundry. That's probably the most common decision point that you'll face. All right. In the next lecture, we're going to zoom in on agent types, the specific differences between prompt and response agents, task agents, and autonomous agents. We'll cover when to use each one and how they map across all of these platforms that we just discussed. All right, I'll see you there.
And joining me today to discuss the advancements in predictive modeling is Unit 7, demonstrating how our AI integrates seamlessly with the new platform.
Microsoft defines 3 main agent types, and they're organized by how much autonomy they have. And this is really the key distinction. First up, prompt and response agents. These have low autonomy. They wait for the user input, they process it, and maybe they do some reasoning, and they give you an answer. But they don't go off and do things on their own. So think of it as a chat bot, a chat-based support bot that answers questions, or a simple Q&A type system. The user asks, the agent answers, and that's it. Second, task agents. These have some autonomy, medium autonomy. They can actually execute bounded tasks using tools. Keyword here is bounded. They're not going rogue. They might escalate an issue to a human, or look up data in a system, or trigger an approval workflow. But they still typically need a human to kick things off. Third, last, is autonomous agents. These are in the high autonomy, heavy hitter section. They can plan, reason, and act independently over multiple steps. Picture a supply chain monitoring agent that proactively watches inventory levels, flags issues and before they become problems, and even adjusts the orders automatically. Now here's the trade-off you need to understand for the exam. Higher autonomy equals more power, but also more risks. An autonomous agent can do amazing things, but it can also do amazing damage if something goes wrong. That's why governance matters so much with these. Here's a simple framework for exam scenarios. So when you see a question, ask yourself these 3 things. Does it need user input to start? If the answer is just responding to what someone asks, that's prompt and response. Does it need to use tools or take actions? Now you're in the task agent type territory. Does it need to work independently, plan its own steps, run in the background? That's the autonomous agent. Now, let's map these agent types to the platforms that we covered in the last section. Copilot Studio supports all 3 types. That's right, all 3. You can build prompt and response, task, and autonomous agents there with an intuitive configuration. It's good for rapid development when you don't need a lot of heavy customization. The Azure AI Foundry enhances autonomous agents. So when you need custom models or sophisticated reasoning or a multi-agent orchestration, that's when Foundry comes into play. Your standard model's not cutting it, Foundry. Dynamics 365 comes in with pre-built tasks and autonomous agents for sales and service scenarios. These are purpose-built for those domains, no coding required. And Microsoft 365 Copilot is mostly prompt and response. It's helping you with your documents, your emails, your meetings, but you can extend it with custom agents from Copilot Studio if you need more. Let me give you a classic example. A company wants a proactive supply chain agent that monitors inventories and flags issues before they escalate. What type and platform? Well, the answer is autonomous agent, because it needs to work proactively without waiting for user input. And the platform, either Copilot Studio or Foundry, depending on the complexity. If they mention needing custom models or complex reasoning, then you're going to lean towards Foundry. If it's simpler, Copilot Studio can probably handle it.
That was a good lecture, but the next one is even better.
Copilot Studio lets you build agents without writing code. That's the headline. But what makes it powerful is how it structures that building process around 4 core components. Let me walk you through each one. Topics. These define conversational triggers and branching logic. Basically, topics answer the question, what conversation paths does the agent handle? When someone says, I need help with my order, a topic recognizes that intent and starts the right conversation flow.
Tools
are the tool calls and the integrations.
Tools
answer the questions, what can the agent actually do? An action might send an email or create a record in a database or call some external API. This is where the agent stops just talking and starts doing. Now, connectors, there are over 1,000 pre-built connections to the enterprise systems. Dynamics, SharePoint, Teams, Dataverse, you name it. Connectors answer the question, how does the agent access data? They're the bridges to your actual real business systems. And knowledge. These are grounding sources that keep the agent accurate and reduce hallucinations. You can connect to SharePoint sites, websites, uploaded documents. The agent answers from your data, not just from what it learned during training. Here's how these components work together in a typical design flow. Step 1, a topic detects the intent from the user input. Someone types something and the topic recognizes what they're asking for. Step 2, an action calls a tool or an external service. The agent needs to do something, so it triggers an action. Step 3, a connector fetches or updates data. That action uses a connector to talk to an actual business system. Step 4, a knowledge source provides context. Maybe the agent needs to look up a policy document or an FAQ or content to formulate a good response. Step 5, the response is generated and sent back to the user. Now, as I've said before, here's something that the exam really emphasizes. Copilot Studio comes with built-in security features, content filters to block harmful outputs, data loss prevention policies to control what data can flow where, environment isolation so that you have separate development, test, and production environments, and role-based access control to all of those. So here's your exam tip for this section. Questions often favor designs that show strong grounding and guardrails. If you see a scenario where the answer includes use Copilot Studio with knowledge grounding plus DLP, that's the safer, smarter choice. The exam rewards you for thinking about governance.
All right, I want to give you just a real quick overview of what you can do with Copilot Studio.
So I'm here on the home screen, and you can see there's some options to create workflows or agents. You can also build these by selecting one of these items here. So if I say choose this create an agent, then I can kind of fill in the parameters, or I can just describe what I want the agent to do. So I might type in something like create a customer service agent, and it's going to give me about what I would get if I click on this. But you could create a more complicated prompt. So I've already created an agent because this does take a little bit of time. I created an agent called customer support agent. So let me just jump over to that, and I'll show you what we configured for that. So you can see we can pick what model we're using, what large language model we're using. We can create a name and a description for this as well. Now, we talked a lot about guardrails. This instruction panel is basically your guardrails. It's where you tell the model what its purpose is and what it is allowed and not allowed to do. This, if you built agents through APIs, this might be considered your system prompt. This is to prevent the user from hijacking your prompt or using what we call a prompt injection attack and getting the agent to do something different than what it was designed to do, because the user has no access to this. And no matter what the user asks our model to do, it will constrain itself to the instructions at a higher level that we provided here. In this particular agent, I've told it that it can't use the internet and it can't use general knowledge. It can only use the stuff that I've provided it. I uploaded a Word document that just contains a product catalog. I'll go ahead and click on Add Knowledge, and it's going to come up, and you can see I can point to a OneDrive directory. I can point to websites, to SharePoint, to a whole bunch of different places where it can find context, things that it's going to look at and use. I've also created a couple of workflows that are listed under tools here. One is to check on the order status, and the other is to create a support ticket. And I'll show you what both of those look like here in just a second. If I wanted to show you what the knowledge or just looking at products might say, what products do you have? Simple bulleted list. And let's see what it comes back with. And it comes back and says, okay, we've got these widgets and gadgets. So those are things that are in that catalog that I listed. Now, to talk about the other parts of this, the workflow, I'm going to need to switch over and show you some databases that we've created. I just created a couple of database tables. So this first one is called orders. There's 4 orders in here. So you can see the data table populate here real quick. And the other one is the support tickets. So you see there's a couple of records there. So let's jump back over to our tool and let's ask about the status of one of these. So I'll ask about order number 1002. That's one of the orders in the database. And so you can see it's kind of giving me a trace of what it's looking at. So it parses out the order information from my query. It goes and looks up in the database the name of the customer, the status, and all of that kind of stuff. Now, it gave me an order status code instead of the actual name of the order status, and that's because of the way we set the database up. That's easily fixable. It's a multi-choice, but the text words. So I'd have to put in an extra condition to have it tell me something about that. Now I'm going to say my order number 2004 shows that it was delivered, but I didn't get it. So let's see what happens here. So we're going to go out and we're going to get the order status again, but this time it ran the other workflow to create a support ticket. So if I go over and look at that database again, so I'll just look at the rows that were created. And you can see that missing order did get put in for the order number 2004. The only other thing that's really kind of of interest here is to look at those workflows, because most of the agentic AI or developing our AI really appears on that single screen where we talked about, described what our agent would do. Here are the two workflows. So the get order status workflow, the agent will provide us with the order number. We told it needs to provide the order number. So it parses that out of what the user typed in and fills that in. And then this next step is to go out and query the database. So our agent provides us with the order number. We've told it how to do the query, and then we tell it what we're going to give back. So we're going to pass back the order status, the order date, the product name, and so forth. And then AI can form its response from that. The create source ticket is very similar. Or we start off with what the agent provides. So the agent's going to, again, tell us what the order number was, but also tells us what the issue was. So again, harvesting that from the prompt that the user provided. So it parses that and figures out what it wants to fill these fields in with. And then we just create a new row in that database. And again, we're mapping from those input parameters. And for the response, we tell the agent to just tell the customer, hey, we created the support ticket. The Copilot Studio has decent tools to help you debug. So when we run these, we can see how they, what they did, what we came up with as a result. I can go over here. You can see my activities. I can go and look at each one of these and see what happened, why it worked or didn't work. And it took quite a bit of debugging to get this to work. To be perfectly honest with you, this did take a little bit of effort because I used Copilot to help me create all of this initially. And it really made a lot of mistakes and a lot of things that really didn't work, especially over in the Dataverse area. So I ended up deleting all of that and going back and recreating it really by hand. And I had a lot better luck with it because I control what everything is named and what's required and not required and things like that. So when I kind of leave it open and asked Copilot to create the individual pieces, it didn't do a really great job, especially on the database side of configuring that for me. It was better at doing it for the agent. It was the database that I had a lot of trouble with.
4 things to remember from this lecture. Number 1, Copilot Studio is your go-to for no-code agents. When speed and simplicity are priorities, this is where you start. 2, master the 4 core components: topics, tools, connectors, and knowledge. They'll come up repeatedly on the exam. 3, the exam loves grounded, secure designs. Whenever you can mention knowledge grounding or governance features, do it. 4, use Copilot Studio when speed and simplicity are the priorities. Don't overcomplicate when this tool can handle the job.
Are you ready for the next topic? Let's go.
Azure AI Foundry is Microsoft's centralized platform for AI model discovery, hosting, and customization. Think of it as your model headquarters. Let me break down what's included. First, the model catalog. Thousands, like 11,000 models are available. Azure OpenAI models like GPT-4, Anthropic's Claude, Meta's Llama family, Mistral, and many more. You're not locked into any one vendor. Second, fine-tuning tools. This is where you can adapt models to your specific domain needs. If the out-of-the-box model doesn't understand your industry terminology, fine-tuning is how you fix that. Third, agent service. This is a scalable runtime for hosting custom agents built with LangGraph or semantic kernel. It handles the infrastructure so that you can focus on the agent logic. Now, here's a key distinction for the exam. Copilot Studio is about speed and accessibility. Azure AI Foundry is for when you need deeper customization, scale, or control. Different tools for different needs.
So when should you reach for Foundry? This exam loves testing this particular decision point. Use Foundry when off-the-shelf models lack accuracy for your industry data, your financial jargon, medical terminology, legal language. If generic models struggle with your domain, that's a signal for Foundry. Use Foundry when you need dynamic routing. That means routing simple queries to cheaper models and complex queries to premium models. It's a cost optimization strategy at scale. Use Foundry when you need multi-agent orchestration or complex custom tool integration. When one agent isn't enough and you need agents coordinating with each other, Foundry provides that infrastructure. And use Foundry when you have strict data privacy or compliance needs. Foundry gives you that. The Azure AI Foundry agent service hosts your agents with built-in scaling, observability, and cost tracking. You're not managing virtual machines, you're just deploying agents, and the platform handles the rest for you. You can also expose your agents via MCP, the Model Context Protocol. We'll cover that in the next lecture. That makes them accessible to other systems and agents securely. So, key capabilities to remember: dynamic model routing for cost optimization, multi-agent orchestration using the agent-to-agent protocol, built-in telemetry and cost tracking, and tool integration via MCP. Here's your exam tip. Questions often contrast quick deployment in Copilot Studio versus custom reasoning and scale in Azure AI Foundry. The answer depends on what the scenario emphasizes. Is it speed? Then Copilot Studio is it. Accuracy, compliance, or scale? Then Foundry. Let me show you the model catalog in Azure AI Foundry. This is where you'll go to discover, compare, and deploy models. We'll navigate the catalog, filter by capabilities, and compare a couple of models and look at deployment options. Hey, let's take a look at Foundry, the Azure AI Foundry, and we're going to go to the portal. That's ai.azure.com, and you'll need to sign in with your account. So first of all, you'll notice on our homepage, I've got one that I've already created from a while back. There's a few models listed here, kind of in a preview, but we can go to the full model catalog here. And there are about 11,000 models in this catalog, so it's a lot. There's a lot of filter options for us here where we can decide what kind of model we're looking for, maybe licensing or whatever it happens to be. Let's take a look at Opus here. If I go to the details screen, you can see we can deploy this model, and we have options on how that deployment takes place. There's full information on pricing, the runtime for this model. Let's jump back and let's take a look at Kimi K2 here. Now you'll notice that with these models, there is a button. It's disabled for this particular model where we can fine tune. So as we talked about with Foundry, this is where we can start with an existing model, and then we can do some fine tuning on that, at least for some of the models. So let's take a look at the filter. So I'm going to go to the capabilities and choose fine tuning, because there are a few models that we can do that with, like GPT 4.1. So we can jump over here. Now you can see that I can use the fine tune button to provide fine tuning. I will need to assign my model to a project. This is true if I want to publish the model as well or use the model. I'll have to create a project to use that. So I'm not going to do that now, but you get an idea for the kinds of things that we can do in Foundry. Remember, for the exam, Foundry is where you go when Copilot Studio's built-in models aren't enough. Domain-specific needs, compliant requirements, or enterprise at scale. 4 things to remember. 1, Azure AI Foundry equals custom models plus agent hosting at enterprise scale. When you hear these requirements, think Foundry. 2, choose Foundry for fine-tuning, dynamic routing, complex workflows, or high-scale needs. Those are your trigger words. 3, always weigh against Copilot Studio. Simpler is better when it meets the requirements. Don't over-engineer. 4, Foundry is the answer when off-the-shelf isn't enough. That's the core decision point. Let's start with MCP, the Model Context Protocol. Here's the key thing to understand. MCP is an open industry standard. It was originally developed by Anthropic, and Microsoft has adopted it across their AI platforms. So why does that matter? Because it means you're not locked into any single vendor's approach. So what does MCP actually do? It lets agents securely request tools, APIs, or context from external servers. Here's how it works in practice. Instead of hard coding an API endpoint directly into your agent, which would be fragile and hard to govern, the agent calls an MCP server. That server acts as a secure intermediary. You can build and register your own MCP servers using Azure functions. You can create a custom service or use existing tools that support the protocol. I've actually written some MCP servers, and they're really pretty easy to do. Why is this better than direct API calls? Well, a few reasons. 1, secure access. You have central control over what agents can call. Instead of the agents reaching out to random endpoints, everything goes through your MCP server, which is governed. Next, auditability. All tool calls are logged and traceable. When the compliance team asks, what did the agent access, you'll have the answer. Next, reusability. You can share MCP servers across multiple agents. Build once, use them everywhere. Interoperability. MCP works across frameworks like Copilot Studio, Azure AI Foundry, and custom code. It doesn't matter where the agent runs. So here's an example you might see. How do you let an Azure AI Foundry agent securely access a private database? The answer, register an MCP server that connects to that database. The agent calls the MCP server. The server handles the database connection with the proper credentials and access control. Clean, secure, auditable. Now let's talk about agent to agent, or A2A. A2A is another open protocol. This one was originally developed by Google, and Microsoft supports it for multi-agent interoperability. Notice the pattern here: open standards, multiple vendors supporting them. That's intentional. It prevents lock-in. While MCP handles agent-to-tool communications, A2A handles agent-to-agent communications. Different problem, different protocol. A2A enables agents to communicate, delegate tasks, and collaborate across platforms. And here's where it gets powerful. Multi-agent workflows. One agent plans, another executes, and a third validates. They coordinate through A2A. A Copilot Studio agent can delegate a task to a Foundry agent. They don't have to be on the same platform. Agents can ask for clarification or hand off complex tasks to more capable agents. For example, a research agent finds relevant documents. It hands those documents to a summarizer agent that distills the key points. That summarizer passes the results to an approver agent that validates everything before surfacing it to the user. 3 agents working together, coordinated through A2A. And it works across platforms. Azure AI Foundry agents, Copilot Studio agents, custom code agents, they can all participate in the same workflow. Here's your exam tip for this lecture. When you see a question about orchestrating multiple agents securely, think A2A plus MCP. A2A handles the agent-to-agent communication. MCP handles the agent-to-tool communication. Together, they cover both bases. Here are 4 takeaways for this module. 1, MCP equals secure, auditable tool access across agents. It's the standard for how agents call external services. 2, A2A equals multi-agent collaboration and delegation. It's how agents coordinate with each other. 3, use both of these standards in the exam answer when it involves governance, scalability, or interoperability. They signal that you understand enterprise-grade design. 4, these protocols enable enterprise-grade agentic systems. Neither one alone is enough for complex scenarios. Let me give you the pragmatic hierarchy that the exam expects you to follow. So start here. Off-the-shelf models plus prompt engineering plus RAG. That's retrieval augmented generation. For most business problems, this combination works. You take a general purpose model, craft good prompts, and ground it in your own data through RAG. Done. Only escalate to custom fine-tuning when that approach fails. And fails has to mean something specific. Domain accuracy is critical, of course. Legal terminology, financial jargon, medical language. If generic models consistently get your specialized vocabulary wrong, that's when you consider fine-tuning. Next could be data privacy or compliance requires tight control. Some organizations need their model to stay on their own infrastructure with their own audit trails. No data leaving their environment. In fact, that's probably most organizations. Fine-tuning lets you create a model that you fully control. Scale demands cost optimization. If you're running thousands of queries a day, a smaller fine-tuned model could potentially save millions compared to paying per token for a premium general purpose model. The math has to work for that to work, though. Proprietary patterns also matter, like internal jargon and specialized business logic that no public model has been trained on. If your data patterns are genuinely unique, and that's rare, by the way, fine-tuning encodes that understanding. Here's the key exam insight. Don't jump to custom models. Try simple solutions first. Be thoughtful about escalation. The exam punishes answers that rush to custom when simpler approaches would have worked. All right, let's say you've done the analysis and custom is genuinely justified. Here's how the Azure AI Foundry process works. Step 1, select a base model from the catalog. You're not training from scratch. You're starting with GPT-4 or open source Llama or another foundation model. Step 2, prepare your training data. This is where most of the work is going to happen. You're going to take that data, clean it, label it, format it for your domain. Garbage in, garbage out applies, and that's double for fine-tuning. Step 3, fine-tune using Foundry's tools. Supervised fine-tuning for most cases, LoRa adapters if you need efficiency. The platform will handle the computation. Step 4, evaluate rigorously, and I mean rigorously. Test for accuracy, for safety, bias, hallucination rate. This exam emphasizes this. Deploying without proper evaluation is always a wrong answer. Step 5, deploy to agent service. Once the evaluation passes, you can deploy. The service scales automatically. Step 6, expose via MCP. Now, other agents can call your custom model securely, just like any other tool. There's also an advanced option, dynamic routing. You can blend models, send simple queries to a cheap model, route complex queries to your premium fine-tuned model. Cost optimization at inference time. We actually do that with our development tools. With VS Code, for instance, we have the option. We've got about 15 models to choose from, and we have the option to have it choose one that might be less expensive for a particular issue. Multi-agent orchestration so that your custom models can participate in larger workflows, and built-in telemetry and governance. So that way you can track usage, cost, and even hallucination rates over time. Now here's your exam tip. Answers on the exam favor the phrase start simple, escalate thoughtfully, with strong governance and evaluation. If you see a scenario where outcome jumps straight to custom models without trying prompts for RAG, for instance, first, it's almost always a wrong answer. 5 things to carry with you from this lecture. 1, custom models solve domain accuracy and compliance gaps. 2, Azure AI Foundry provides the tools for fine-tuning, for evaluation, and for hosting. It's your custom model headquarters. 3, always justify with business trade-offs in exam scenarios. Cost, governance, performance. Show you're thinking about the whole picture. 4, evaluate first, deploy second, monitor continuously. The exam never rewards skipping evaluation. 5, start simple, escalate thoughtfully. That's the exam mantra. Burn that into memory.
That was a fun topic, but the next one is even better.
This is 25 to 30% of the AB-100 exam, so pay attention. In this section, we're shifting from tools and platforms to strategy and business alignment. We'll analyze requirements, figure out data readiness, and calculate real return on investment. By the end of this lecture, you'll know exactly how to assess whether Agentic AI is the right fit for your given business problem. Let me start with what separates a good plan from a bad one. It always begins with the same 3 questions. First, what problem are we actually solving? What's the business outcome that we want? Don't skip this part. We need to know the goal. Second, what are the constraints? Is it budget? Is it timeline? Regulatory requirements? Data access? These all matter a lot. Third, does this really need an agentic approach? That's the critical question. Does the task involve multiple steps? Does it need to call tools or APIs? Does the agent need to adapt when things don't go as planned? Here's how to think about it. Agentic AI works best when the task has real variability and requires multi-step decisions. For example, evaluate this contract and flag risks and suggest approvals. That's a strong candidate. The agent needs to reason through the legal lingo, through the clauses, check a knowledge base, and escalate those edge cases. Other good fits include ambiguous processes like supply chain exception handling, tasks that require calling multiple tools or API, and high compliance scenarios where the agent operates with guardrails. On the other hand, if the task is purely repetitive and rule-based, like if customer status is gold, apply 15% discount, that's not agentic. A Power Automate flow handles that just fine. Simple question and answer without follow-up actions, standard Copilot. Static single-step processes, well, traditional automation in that case. The exam loves testing this distinction. Wrong answers often apply agentic AI to problems that a simple workflow would have solved. Here's the framework I use when I'm planning a solution. 4 steps. First, your goal. What outcome are we after? And sometimes that's really hard. I've had trouble getting my customer to even tell me what that is. Second, constraints. Budget, timeline, regulation, team skills. What is it that's limiting us? Third, fit. Does agentic AI actually make sense here in this circumstance? Fourth, recommendation. What solution do we propose? Let me walk through an example. Let's say a client comes to you and says, we want to automate contract review with approvals. Our goal, faster processing, fewer human errors. Our constraints, well, highly sensitive data, strict compliance requirements, and legal team will need visibility as well. So is it a fit? Yes, the agent can review contract clauses against a knowledge base, can call tools to check regulatory databases, it can identify issues, and it can escalate edge cases to our lawyers. That's a strong agentic workflow. Recommendation here, build a task agent with guardrails and a clear escalation path to the legal team. So here's your exam tip. The best answers balance ambition with realism. We can build something powerful paired with, here's how we mitigate the risks. Don't oversell. Here's something a lot of people skip, risk assessment. You can't just analyze what you want to build. You need to analyze what could go wrong. Every agentic AI initiative carries risk. Here's a simple framework with 3 dimensions. Likelihood. How likely is it that this risk materializes? Is it data quality issues? Very likely. Complete system outage? Well, that's less likely, but it is catastrophic if it happens. A hallucination in an internal frequently asked questions? Well, low impact, but a hallucination in a financial recommendation to a customer, well, that has high impact. Mitigation, well, that means what do we do about it? Well, add guardrails, require human review, set up monitoring, or fall back to a manual process. Let me give you a quick example using that contract review agent. There are 3 risks. 1, data staleness. That likelihood is medium. Impact is high because the agent could use outdated regulations. Mitigation, automated data refresh with alerts. Hallucination on edge cases, likelihood is also medium. Impact is high because that's bad legal advice. Mitigation, mandatory human review for any flagged risk above a certain threshold. Scope creep. Likelihood is high because someone always asks, can the agent do X? Impact is medium, and the mitigation is to have clear scope boundaries documented in our project charter. So an exam tip is when a scenario asks you to plan or recommend a solution, include at least 1 risk and its mitigation. That shows mature thinking. The exam rewards candidates who think about what can go wrong, not just what should go right. 4 things to lock in. First, always start with goal and constraints. This is foundational. Second, agentic AI shines in an adaptive, tool-heavy, multi-step process. Third, assess risks early, like likelihood, impact, and the mitigation. Fourth, use trade-off thinking in the exam scenarios. There's always a balance to strike. Let's start with what grounding actually means. Grounding is giving your agent real context to work with. Instead of letting the agent make up answers, you connect it to actual data sources. You might use retrieval augmented generation, which we call RAG, RAG, or connect to enterprise systems through connectors, or point the agent at knowledge bases. Without grounding, what happens? The agent hallucinates. It invents facts that sound plausible but are completely wrong. And it will be very confident in providing those wrong answers to you as well. You don't want that. So here are the 3 dimensions you always assess. First, quality. Is the data accurate? Is it current? If you're pulling from a spreadsheet that hasn't been updated since 2023, that's a problem. Second, relevance. Does it match what the agent is actually trying to do? A knowledge base about product specs might be useless if the agent needs customer service history. Third, availability. Can the agent access it securely, quickly, and reliably? If the data is locked behind permission layers or scattered across different systems, that breaks the agent. When you're getting ready for a solution, walk through this checklist. Check for outdated data. That's your first warning sign. Check for silos. Is the data spread across different systems with no integration? Check for permissions. Can the agent actually access it? Check for governance. Is there a data owner? Are there policies around that data? The good news, Microsoft makes grounding easier than it used to be. In Copilot Studio, you can add knowledge sources directly. You saw that in our earlier demo where I put a Word document, but you can provide all kinds of sources. Point it at a SharePoint document or a Dataverse database or a public website. That's simple. In Foundry, you can build more advanced RAG pipelines. If you need custom retrieval logic or you need to handle specialized document types, you have the flexibility. With Power Platform connectors, you can access enterprise systems directly, SQL databases, CRM, ERP systems. The agent can pull live data. Now, here's what I want you to focus on in the planning phase. Your job is to assess whether the data is ready and identify gaps in that. The detailed architecture for how to organize and connect that data comes later. We'll cover that in Lecture 8 on data interoperability. Right now, you're asking, is the data good enough? And if not, what needs to change before we build? So an exam tip that you'll see scenarios like our customer data is scattered across 3 legacy systems and the product knowledge base hasn't been updated in 6 months. Your answer should be assess readiness first, identify quality, relevance, and access gaps. Recommend a governance approach and establish data refresh cadence before building that agent. That's proactive risk mitigation. 3 things to remember. First, grounding prevents hallucinations. Assess it early. Don't skip this. Second, focus on the 3 dimensions: quality, relevance, availability. And third, in exam answers, show proactive risk identification. Say what you'll do about data gaps before you build. You know, I've mentioned a time or two in the course that security is very important, and the exam emphasizes that. And having garbage in, garbage out is, in effect, a security issue. So AI getting things wrong is always going to be a risk that the exam wants you to identify and avoid. How do you take agentic AI from a single pilot to a sustainable, governed, organization-wide strategy? That's what this lecture is about. We'll use the Microsoft Cloud Adoption Framework, or CAF, for AI. CAF or CAF is basically a roadmap. It breaks adoption into 5 phases. Let's walk through each. Strategy. This is where you define your vision. What are the high impact use cases? For Agentic AI, think customer support escalation or contract processing, supply chain optimization. You're setting the direction here. Second, plan. Now you build the roadmap. What data do we have? What data do we need? What skills are missing? What's the timeline? You're starting to turn that vision into reality. 3, ready. Infrastructure and governance. You're setting up your cloud environments, defining security policies, and establishing who owns what. 4, adopt. This is the pilot and the scale phase. You start in Copilot Studio, run a pilot, prove the value, and then expand from there. And last, govern. Ongoing compliance, monitoring, and updates. This is where governance tools like Purview come up. You're staying compliant and you're managing risks continuously. Here's where a lot of organizations go wrong. They think of CAF as a linear process. Do strategy and then move on to plan. Well, that's not how it works. All 5 phases are ongoing with some activities in parallel. Let me give you a concrete example. In the strategy phase, your executive team identifies 3 high-impact use cases. Customer support escalation tops the list. Plan phase, you assess data readiness, the customer histories, knowledge base, team skills, and then timeline. Your ready phase, you set up a development, test, and production environment in Azure. You establish data loss prevention policies and create your security guidelines. The adopt phase is where you'll build the agent in Copilot Studio, run it with a small customer service team, and measure your results. The govern phase, you'll monitor with Purview. You'll track your agent accuracy, log escalations, and adjust the system. But the key insight is that as you move through adopt, you're already back in strategy and plan for use case number 2. CAF is iterative, not sequential. Also, one more crucial piece. Build an AI center of excellence. This is a cross-functional team that centralizes governance, standards, and best practices. I've noticed with a lot of AI systems that there's a lot of almost mutually exclusive skill sets involved. No one single individual has everything we need to do the whole thing. So we have to coordinate efforts of a lot of disparate personality types in people. Now, let me talk about something the exam cares about that a lot of people gloss over, and that is how to design a pilot. A pilot isn't, let's try and see what happens. A well-designed pilot has 5 elements. First, scope. Pick a bounded use case. Not something like automate all of customer service. Something more like handle password reset and account status inquiries for the North American support team. Very specific. Second, duration. Set a time frame. Like 6 to 8 weeks is typical. Long enough to get meaningful data, but short enough to maintain that urgency. Third, define your success metrics. Define these before you even start. Resolution rate, customer satisfaction score, average handle time, your escalation rate. If you don't define success up front, you can't prove it afterward. Fourth, your go or no-go criteria. What results mean scale this up versus let's stop and rethink? Be specific. If the resolution rate exceeds 70% and customer satisfaction stays above 4, we'll proceed to a full rollout. Fifth, your feedback loop. How are you collecting user feedback during the pilot? Like weekly check-ins with the support team? Are you doing automated surveys after each interaction? This data will feed your improvements. A structured pilot with a clear success criteria beats will deploy and monitor every single time. 4 things that we need to remember. First, CAF phases guide structure adoption, but they're iterative, not linear. Second, build a center of excellence, CAE, to centralize governance and prevent silos. Third, design pilots with clear scope, metrics, and go or no-go criteria. Fourth, align your strategy to your business outcomes. That's what the exam is testing. Next, one of the most common decisions you'll face, build versus buy versus extend. This is where theory meets practicality. Should we build this agent ourselves, buy a pre-built solution, or extend what we already have? This lecture walks you through that decision making. Let me give you a decision tree that actually works in real organizations. Build. You're writing custom code. Maybe you're using Copilot Studio with heavy customization. Maybe you're using the SDK. Maybe you're fine-tuning models in Foundry. This is where you have a truly unique workflow that no vendor solution covers. You have deep expertise on staff, and you have the time and budget. Buy is where you're getting something off the shelf, like Dynamics 365 Copilots or Copilot for Sales, Copilot for Service. This is where the solution covers 80% or more of what you need right out of the box. Your team lacks the expertise to maintain custom code in the long term, and you want Microsoft support and regular updates. And then extend. This is where you're taking a vendor solution and customizing it. This is actually the most common scenario. You start with a Copilot Studio solution, and then you customize your prompts, your connectors, and actions specific to your business. The real answer in enterprise environments, well, most projects are extend. Buy the foundation, customize on top. Here's the practical trade-off. Build has, of course, the highest upfront cost and the longest timeline, but you get exactly what you want and full control of it. The downside is that you own all the maintenance and the updates, and oftentimes that's actually more expensive going forward than the initial development. Buy is the fastest way to value. You're live in a few weeks, but you're constrained by what that vendor gives you, and you'll need workarounds for your edge cases. Extend is your middle ground. You get to the market reasonably fast, and you have vendor support, but you add customization on top. Let me give you 3 quick scenarios and show you how you think through them. Scenario 1, a manufacturing company wants an agent to optimize production schedules based on real-time supply and demand data. This is highly domain specific. Their thinking is we could buy a generic scheduling tool, but it won't understand our specific constraints. Our decision, build. We need custom algorithms and tight integration into our existing manufacturing systems. Scenario 2 is a financial services company that needs a Copilot for customer service that handles basic FAQs and escalates complex requests to humans. This is kind of standard. They're thinking Copilot for Service does almost everything we need right out of the box. We'll extend with one custom connector for our internal policy database. Fast, supported, low risk. Scenario 3 is a retail chain that wants to personalize product recommendations using your customer purchase history and their browsing behavior. This is a common problem, but they have unique data. So their decision is we'll extend. We'll start with Azure AI Foundry and connect it to our product catalog and our customer behavior database. So we're not building from scratch, and we're not buying an off-the-shelf solution either. We're extending from a base. So the pattern is the decision comes down to 2 things. How unique is your problem, And how much expertise do you have on staff? And I found a lot of customers think that their problems are really super unique when they're actually not unique at all. Here's an exam tip. The best answers show that you understand the business trade-offs, not just the technical options. We'd extend Copilot Studio because it gives us a baseline functionality fast, reduces our maintenance burden, and we can add our specific connectors on top. Always beats, we'll build everything ourselves because we need total control. So 4 things to remember. First, build when the problem is truly unique or you have deep expertise, or really both. Second, buy when the vendor solution covers 80% or more of your needs. Third, extend, and that's usually the answer in an enterprise. Take a vendor solution and adapt it. Fourth, always factor in maintenance cost and ongoing cost of ownership. Also, your team expertise, not just the initial delivery. Next, we're going to get into cost modeling and return on investment calculation, because even in the best technical decision will fall apart if you can't justify the business case. This lecture teaches you how to calculate real return on investment and total cost of ownership for the Agentic solutions. These calculations show up frequently on the AB-100 exam, so learn these. All right, let's define total cost of ownership. It's not just the cost of tokens you're consuming. TCO includes everything. That's development cost, building the agent. Copilot Studio might be $200,000 in consulting. Azure AI Foundry custom development might be $500,000 or more in inference cost. Actually running the agent, each API call costs money. This is where model routing helps. Our cheaper models for simpler tasks reduce inference cost dramatically. Azure compute, storage, logging, monitoring, these are typically small relative to development, but they're ongoing. Also, governance and operations, security scans, compliance monitoring, your staff time to maintain and update the agent. Don't underestimate this cost. A 24/7 support agent needs monitoring, incident response, periodic retraining. Change management costs. Training your team, adapting processes, managing adoption. When requirements change or performance drifts, there's rework. So here's the table that breaks it down. Development, usually 20 to 30% of total cost. Model and inference, that's 25 to 40%, depending on your usage volume. Infrastructure, 10 to 20%. Governance and operation, 10 to 20%. And change management, 5 to 15%. Now, the way you reduce TCO, model routing, for instance, that reduces inference costs significantly because you're not paying premium prices for simple queries. Reusing agents and prompt libraries reduce development cost because you're not building from scratch each time. Microsoft Purview and automated alerts reduce operations cost, and phased pilots reduce your risk because you're not betting the whole organization on one big build. Now, the return side. ROI equals benefit minus TCO divided by TCO. So let me give you a concrete example with customer support automation. So with setup, you currently have, say, 50 support agents, each handling 10 tickets per day. The proposal is to deploy an AI agent that handles 40% of the tickets, the simple request and the tier 1 issues. That frees up 20 agents worth of capacity. The benefits are 20 full-time positions at $70,000 each equals $1.4 million in labor reallocation. That also means faster first response, 5 minutes versus 2 hours on average. That improves customer satisfaction. Estimate a 5% reduction in churn. If annual revenue is $50 million and churn was 3%, that's $750,000 in saved revenue. So the total annual benefit, $1.4 million plus $750,000 equals $2.15 million. Okay. Cost, on the other hand, so your year one development is $400,000 for your Copilot Studio setup in integration with the help desk system. Year one inference is 20,000 tickets per month times 12 months at 5 cents per ticket. That's 120,000. Year one infrastructure in operation is 80,000. So total year one TCO, 600,000. So ROI year one, 2.15 million in benefit minus 600,000 in cost divided by 600,000 equals 258%. That's compelling a business case. You might even achieve ROI in the 3 to 4 months, like break even in 3 to 4 months operationally. So here's the exam insight. Your answer should include all cost, not just development. It should be realistic. Not we'll save $5 million and it costs nothing. And it should show phased thinking. Year one, we pilot with tier 1 support. Year 2, we expand to tier 2. This reduces risks and lets us prove value before scaling up and out. That's risk-aware business thinking. The exam rewards that. 4 things to remember. First, TCO includes development, inference, and infrastructure, as well as governance and change cost, not just tokens. Second, ROI is benefit minus cost divided by the cost. Use realistic, provable, quantifiable numbers. Third, show phased approaches to reduce risks and demonstrate value early. As a software developer, I can tell you it's always a benefit to get features in front of your customer as soon as possible. Even if it's a work in progress, the faster you show progress, the more buy-in you get from that customer. Fourth, identify cost reduction opportunities like model routing and reusable components. Next, prompt engineering and prompt libraries, because even a well-justified solution needs consistent, reliable prompts to actually work. The last thing we want to have happen is to have a great idea that we can actually justify from a money standpoint and then fail in the implementation. In this lecture, we'll cover how to write effective prompts and how to scale them across your organization. Think of the prompt as the agent's constitution. It defines what the agent cares about, what its priorities are, and when it should ask for help versus deciding on its own. I'll give you the key techniques at a high level. Chain of thought prompting. Ask the agent to reason step by step before answering. This gives you transparency. What we call few shot examples, that gives the agent 2 or 3 concrete examples of good answers. Examples beat descriptions every time. Also, role prompting. Tell the agent what role it's playing. Context changes behavior dramatically. Now, your guardrails. These are boundaries that prevent bad decisions. For instance, never approve without legal review of IP rights are involved. This table summarizes it. Chain of thought improves reasoning. Few shot ensures consistency. Role prompting adds context. And guardrails prevent errors. You already practiced these techniques in the design section. For planning, the key insight was that prompts are a strategic asset, not an afterthought. Now, here's where most of the organizations fall short. They write a great prompt for one agent, and then 12 months later, A different team writes basically the same prompt from scratch, and it's subtly different and inconsistency spreads. Now, the solution is a centralized prompt library. This is a repository where you categorize prompts by their use case, like customer service or finance or HR. You track test results and performance notes, and you include a change log so that people understand what changed and why. It's like just a typical GitHub project, right? When someone needs a new agent, they browse the library, find a similar prompt, and adapt it rather than starting from scratch. You get consistency, faster deployment, and continuous improvement. Let me expand on governance because this is where the planning value really lives in ownership. Every prompt template should have an owner, a team, or an individual that's responsible for maintaining it. Just like you wouldn't deploy code without an owner, prompts need accountability as well. They need a review process. Before a prompt goes into production, it should be reviewed. Does it include guardrails? Does it handle edge cases? Is it consistent with your organization's tone and policy? Also, your testing cadence. Prompts can drift in their effectiveness as models update and your business rules change. Schedule reviews periodically, like quarterly at the minimum, for your prompts. Now, cross-agent consistency. If your organization has 15 agents in customer service, everyone should follow the same escalation guidelines. So you define one escalation prompt template. Like if the customer is frustrated with an issue, or the issue involves a refund exceeding so many dollars, or the issue requires legal interpretation, escalate to a human. Every agent should use that template for consistency and coverage. Now, a prompt works really well, so you update it to version 1.1 with new edge cases. You can push that to all the agents at once. This ties directly to the Cloud Adoption Framework, remember CAF, and our Center of Excellence we discussed earlier. The Center of Excellence, the COE, should own the prompt library. It's a governance function. So here's an exam tip. Answers that include, we would establish a centralized prompt library with versioning, ownership, and governance score very well on the AB-100 exam. It shows you understand scaling and consistency. So there's 4 takeaways, 4 things to remember. First, understand core techniques, chain of thought, few shot, guardrails. You applied them in design. Second, build a centralized prompt library to ensure consistency across your agents. Third, govern prompts with ownership, review processes, and versioning. Fourth, tie prompt governance to your center of excellence and organizational strategy. Next, model selection and routing. Not every task needs a cutting-edge model, and some will need specialized models. So let's talk about how to choose. Model routing is the strategy of matching tasks to the right model. This lecture shows you how to think about routing and when, if ever, you actually need custom models. Let me start with economics. A large, sophisticated model costs more per call than a smaller, faster model. So the question becomes, can I get good results with a cheaper model for this particular task? That's what model routing is. You set up rules so simple tasks like, is this email spam, go to a lightweight model. Complex tasks like, summarize this contract and flag legal risks, go to a premium model. The key part, in Azure AI Foundry, you can make this automatic and dynamic. You don't have to manually say, use model A under this condition or use model B under this condition. Instead, the system evaluates the query complexity and routes accordingly. Let's make this concrete. Picture a customer support agent. A customer says, "My password isn't working." That's a simple query. Route to a lightweight model. Response, "We'll reset that for you. Check your email." The cost, a fraction of a cent per call. Now, the same agent, but a different customer. This customer says, "I'm on the enterprise plan, but this particular feature isn't working, and it was working last month. This is blocking our workflow." That's complicated. The root cause might be a setting change or a bug or a feature update. So we're going to route that to a premium model that can explore the context, ask for clarifying questions, and provide detailed troubleshooting. This is going to cost a few cents per call. And doesn't sound like much of a difference, but over thousands of calls, routing intelligently saves you real money while keeping the quality where it matters. So, what criteria do you actually use to build routing rules? There are 4 key dimensions. One is query complexity. Simple yes or no questions. Route to the cheap model. For open-ended analysis, route to premium models. Latency is also important, so time-sensitive tasks might justify a faster model even if it costs a bit more. So also cost targets. If you're targeting a specific cost per query, build that threshold right into your routing rules. In addition, your accuracy requirements. Safety critical or compliance sensitive decisions always need your best model. The key is combining these. A real routing policy balances all 4 dimensions based on your business priorities. Now, here's the important question. When do you go beyond routing and prompt engineering to actually build a custom model? The answer, not very often, rarely. But there are 3 clear triggers. First, domain accuracy. That's mission critical. So, for example, a legal document analysis. The cost of a hallucination here is lawsuits. So you would want to fine-tune a model on thousands of real contracts from your firm. It learns your specific language and your tone, as well as your risk patterns and your edge cases. The upfront investment is worth it because the cost of failure is enormous. Second, compliance demands isolation. For example, a healthcare company with strict data residency requirements. Patient data can't leave your environment. You deploy a fine-tuned model in your own Azure subscription. There you have full control and full compliance. Third, long-term volume. That would justify the upfront cost. Let's say you're processing 1 million emails per year. A 2% accuracy improvement saves $500,000 in downstream issues. Fine-tuning costs $50,000 up front, and so it pays for itself in about 3 months. Here's the exam insight, and this is critical. Most scenarios don't hit these thresholds. The best answer on the exam is almost always start with routing and advanced prompting, evaluate performance with clear metrics, and only escalate to custom models if evaluation shows persistent gaps you can't close in any other way. Think of it as an escalation ladder. Routing is the first rung. Prompt engineering and grounding come next. Custom models are the top rung, and most organizations never need to climb that high. That's the pattern the exam rewards. You're not over-engineering. You're solving with the simplest effective approach and escalating only with evidence. So 4 points to remember here. First, model routing balances cost and performance dynamically. Use it as your first move. Second, custom models solve specific problems only where routing and prompting aren't enough. Third, always justify model decisions with metrics. accuracy improvements, cost savings, and compliance needs. And fourth, on the exam, show you understand the trade-offs and start with the simplest, effective approach. Next up, organizing your business data for AI interoperability, because even the best model strategy falls apart if the data that's feeding your agents is siloed and inconsistent. This lecture is about architecture. How do you actually organize data so that multiple agents and systems can use it consistently and securely? Let me start with the problem. Most large organizations have data scattered across all kinds of systems. You have CRM data in Dynamics 365, product data in a legacy database, customer service tickets in Zendesk, knowledge articles in SharePoint, financial data in SAP. Now you want to build an agent that helps customers. That agent needs access to all of that to give good answers. But if the data is in silos, like different schemas, different formats, different governance models, the agent gets confused. It will hallucinate because it doesn't have consistent context. That's what interoperability solves. You architect the data layer so that information flows consistently and securely across all these different systems. And here's the thing, this is not a one-time project, it's an ongoing practice. So here are 3 practices that matter. First, semantic organization. Define common terms. So like customer should mean the same thing across all of your systems. Order status should mean the same thing and have consistent values. You're creating a shared vocabulary that agents can understand. Second, governed access. Just because an agent can access customer data doesn't mean that it should. Set permissions and audit access. Ensure compliance. If you're touching regulated data, you need to track it. Third, real-time or near real-time synchronization. If the agent reads from a data copy that's 3 days old, it will always give stale answers. You need systems that keep data fresh. So those are your principles. Now, let's look at the specific tools that Microsoft gives you to put them into practice. So first off, there's Purview. This catalogs all of your data. It scans your Azure resources, your SQL databases, SharePoint, and creates a unified catalog with lineage. Where does customer data live? What's the quality? Who owns it? Purview answers that. Next, there's Dataverse. This is your common data platform. Different systems can write to the Dataverse using connectors, and agents query Dataverse directly. It has built-in governance and relationship tracking. In fact, you saw us use Dataverse in the Copilot Studio example earlier. Not everything goes into Dataverse, but your most critical business entities should. Connectors and Model Context Protocol, or MCP, these integrate external systems. A connector pulls data from your legacy database into the Dataverse. Model Context Protocol, or MCP, allows agents to interact with external systems in a standardized way. Here's the architecture I recommend. And this is the pattern you'll want for the exam. 4 layers. Layer 1 sources your existing systems. That's Dynamics, SAP, SharePoint databases. You don't need to replace anything here. Layer 2, your catalog. Use Purview to map and classify everything. You're not moving data anywhere, you're just creating a map. Layer 3, common platform. For critical business data, pull it into Dataverse for transactional data like customers and orders, or Fabric for analytics and reporting. This is your single source of truth layer. Layer 4, your agent access. Your agents can query Dataverse with governance built in and use connectors to reach systems that don't feed into that common platform. So that's your blueprint. Now let me show you what it would look like in the real world. So let's say in a healthcare organization that we have patient data that lives in an electronic health record system. Insurance data lives in a separate claims system, and billing data is in yet another system. You'll use connectors to sync the critical fields like patient ID, insurance status, account balance, and things like that into Dataverse daily. You'll set permissions so that agents can see the data that they need to be able to see. A front desk agent sees insurance status, but not medical records. An agent answering patient questions like, what is my copay? Well, that pulls from the Dataverse, fast and governed and consistent. Or a patient might ask, what test did I have last year? That goes to the electronic health record system via secure connector. That's interoperability. Data is organized, governed, and accessible. And here's your exam tip. When you see a scenario about scattered and inconsistent data, think through it layer by layer. Catalog with Purview, pull critical entities into Dataverse, connect the remaining systems, and then lock down governance for agent access. If your answer touches all 4 of those, then you've nailed it. So here are our key takeaways. 4 things to lock in. First, siloed data causes agent failures. Interoperability is foundational. Second, semantic organization means consistent terminology across all systems. Third, leverage Purview for cataloging, Dataverse for critical data, and connectors for integration. And finally, fourth, governance. Governance and access control to prevent compliance violations. So next, we have our final lecture of Section 3, Pre-Built Agents and when to use them. Do you always need to build from scratch? And the answer, of course, is no. Sometimes the fastest path is using what Microsoft already built, or even using a smaller specialized model. In Lecture 4, we covered the build versus buy versus extend framework. And you already know that buying or extending is usually the first choice. Now let's get specific about where pre-built agents deliver the most value. So we have Copilot for sales. That's the best fit for deal management workflows. It summarizes customer relationship, suggests next actions, drafts emails, all grounded in your actual CRM data. If your team spends hours manually preparing for customer calls, this is of immediate value. There's also Copilot for service. This is best for frontline support. It will suggest solutions from knowledge articles. It will draft responses. It handles escalations. The return on investment story here ties directly to what we calculated in Lecture 5. Reduced handle time, higher resolution rates. Now, Copilot for Microsoft 365, this is best for productivity across your applications like Teams and Word, Excel, Outlook, meeting summaries, email drafting, and document creation are all of the features of the Copilot 365. The key insight for planning: pre-built agents are your fastest path to demonstrating value. They're ideal for pilots. You activate one, customize the prompts in Copilot Studio using your prompt library, and you're running in weeks or even days. That's why we said buy first in Lecture 4. But pre-built agents have limits. Highly specialized industry workflows and deeply customized integrations, processes that don't map to the standard CRM, ERP, or productivity patterns. In those cases, you need to extend the pre-built capabilities or step into a different category entirely, like small language models. So what are small language models? Well, models like Phi-3, which Microsoft developed. Here's a helpful analogy. GPT-4 is a truck. It's massive, powerful, can haul anything. Phi-3 is a scooter. It's small, nimble, and efficient. And it's actually faster for most people's daily commute. You don't need a truck to go get coffee. Just kind of keep that image in mind. So why pick the scooter? Well, 4 reasons. First, cost. Phi-3 is dramatically cheaper per inference. When you're processing 1 million customer inquiries per month, that adds up pretty fast. Second, privacy. You can fine-tune Phi-3 on your proprietary data and deploy it in your own Azure environment. Your data never leaves your organization. Third, latency. Smaller models are faster. Phi-3 can run on edge devices, your manufacturing floor, your retail store, without waiting for a cloud round trip. And fourth, specialization. You fine-tune on domain-specific examples, and the model learns your terminology, your processes, your decision patterns. It becomes an expert in your business. Let me give you 2 concrete examples. So thousands of sensors are streaming data. You need an agent analyzing anomalies and recommending actions with latency under 100 milliseconds. So sending data to the cloud for a large model query, that's too slow. So we'll take Phi-3, fine-tune, deploy it locally. It runs in 50 milliseconds, saves 40% on inference costs, and never sends sensitive sensor data outside of the plant. Another example is financial services. Let's say you have trading rules that are proprietary. Fine-tune Phi-3 on your domain language and decision patterns. Deploy it internally so you have fully governed access. You get a performance and a cost advantage over a generic large model. Now, here's the exam insight. The best answers show pragmatism. So we'd start with a pre-built Copilot for service because it covers 80% of our needs. For that specialized edge case, we'd evaluate small language models because of lower cost and privacy benefits. Custom large models only if neither pre-built nor SLMs will get us there. That's thinking like a business technologist. You're solving problems with the simplest, most cost-effective approach first. 4 points to take with you. First, pre-built agents are your first choice. Fast, governed, lower cost. Second, small language models excel for specialized, privacy-sensitive, high-volume tasks. I even have a SLM that I run on my local computer for certain tasks that I do. Third, custom large models are the last resort when neither pre-built nor SLMs will suffice. And fourth, always ask, what's the simplest solution that solves the problem? All right, congratulations. You have completed the first half of our exam prep video. The next video is going to cover the design domain, which is about 25 to 30% of the exam, as well as the deploy and governance domain, which is about 45% of the exam. Make sure you hit like and subscribe to our channel so you don't miss out on future videos. Also, if you want to take this course as a Udemy course, you can take the practice exams along with it. I've got a link in that description below, so take a look. and sign up for that Udemy course as well. My name is Chuck McCullough, and once again, thank you for watching our videos and supporting our channel, and I'll see you in the next one.